All right, so we are in geometry. Today's date is Friday, January 10th, 2020. Please make sure that your name and date are on your paper. Is it the date?
Teacher.
Teacher error. What did I do?
We can't see.
Oh, you can't see. I don't know if that's considered a teacher error, but thank you for letting me know.
Does it say a teacher?
Okay, sure. You guys
Teacher.
It's only like 0.1% of your grade. All right, so who can read our objective for solving similar triangles, the advanced version of it? Julian.
Real quick.
I'm not going to do cards. It's minimum days too fast. Say again, Julian?
Use properties of similar triangles to solve problems with infinite three movements.
That is indeed correct. All right, Etterhood. We're on to example number 1. Is it a question? You know how to do this? Question, yes.
Do we have participants?
I'm going to skip those today because I should have passed them out, and it's my bad, but we have no more time in this class because we have a minimum day, and we spend a ton of time on the warm-up, so I'm going to skip it. All right, so example number 1. We are going to solve this for x. So this is what I mean by advanced similar triangles. These triangles for the homework are going to be embedded in one another, which means you need to unembed them, and that is kind of the hard, tricky part. But if you can actually do it, then you're ready to go. First of all, are these triangles similar? What is the definition of similar with a quiet raised hand? Go back to your notes if you don't remember. 4-1 has a definition of similar. Andres.
So it's actually quite simple. So if they're similar triangles, they should have at least two same angles.
Congruent angles? Perfect.
Congruent angles, and it doesn't have proportional sides.
There it is, yes. The exact definition. You need all of the angles to be congruent, technically only 2, and you can find the third one. That's the angle-angle theorem. And all the sides need to be proportional, which means I need to check for at least 2 angles that are the same. Well, if I go ahead and redraw these, so you're doing this with me, I'm going to draw a tiny triangle. Yoink, yoink. There's a tiny triangle. He's a 3x2 triangle. If I have a 3x2 triangle, and I have a giant triangle over here, we know that this angle right here and this angle right here are the same angle. They're literally the same angle. I'm just copying them. If I place them one over the other, they're the same angle because that's what this piece inside of this piece. I'm really talking about that same angle right here. And I guess I forgot to put it on here. I should really be saying that something along the lines of this line is parallel to that line or something. If I said that they're parallel, and I forgot to leave that in there, but these should be parallel by, these are called corresponding sides. This angle and this angle are corresponding, therefore we have 2 angles that are the same. We can say those 2 angles were the same, and then these 2 angles are the same. Therefore they are similar. But I'm a bad mathematician because I forgot to say that these 2 lines are parallel. If I told you that, then you could conclude that they're similar. Or if I said something along the lines of these are right triangles, then you could also conclude that they're similar, but I forgot to do that, so that's my bad. But now let's assume that they're similar. How do I set up this problem? Well, I know that this length with the quiet raised hand is what? The length of the big triangle right here. Quiet raised hand. Who's got this? Sergio.
5.
It is indeed 5. What about this length on the bottom of the large triangle, this leg down here, assuming it was a right triangle? What is this length down here? Andres has already participated. This one's a little bit tricky. Fernando did the warm-up. Is there anyone else that's brand new? I'll call him Fernando because he hasn't done the lesson yet.
So you see 3 plus x.
That is the hardest part, and you got it, 3 plus x. Most people will mistakenly put x. X is only this part of the triangle, but to get the full part of the triangle, I need to have these 2 added together, 3 plus x. Make sure that you always remember to add those together. That's the most common error when it comes to these types of problems. All right, so I'm going to set up a proportion. My proportion will say this to this is equal to this to this. That's using the definition of similar triangles. So, who can help me set that up? This is kind of stemming from yesterday, building off of yesterday. I want to say this is equal to this as this is equal to this in terms of their proportional. Same 3 people. Come on, I need more hands, otherwise I'm going to cold call. All right, Jose. Let's do big or small on the top.
What is it? The 3
All right, we're doing small on the top.
over 3x, right?
3 over 3 plus x, yep. And that was the big.
And equal to 2/5.
2 over 5. Perfect. Thank you. Just making sure that everyone can follow Jose's work. I'm saying that the small bottom triangle is equal to the big bottom. The small 3 is equal to the big 3 plus x. And then that's equal to the small triangle 2 to the big triangle 5, the corresponding parts. Question, Andres.
Would you have to put the big number on top instead, or?
You could do 3 plus x over 3 is equal to 5 over 2. I could flip both of them, and it would still work.
So any.
It doesn't matter, yeah.
Way it would work.
Yeah, just make sure you're doing small over big, or big over small, big over small. It would be very improper to say small over big is equal to big over small. That wouldn't work. You'll get the wrong answer. All right, so from here I need to solve. I'm going to do what? Jose's already participated. I need to do what? What's this word? Adder, what's this word? Where you cross something. There it is. Cross multiply. Another quad raised hand. How do I cross multiply 2 times 3 plus x? Andres again?
Yeah. 3 plus x.
3 plus x.
Wouldn't that just be 3x though? Like 3 plus x?
3 plus x is just 3 plus x. I can't add them because they're not like terms. And then times,
Times 2.
just like that. All right, perfect. You can write that 2 in front or behind. It doesn't really matter. And Andres, do the other direction as well, please.
Oh, 15.
15, perfect. We have now cross multiplied. Keep your parentheses. That's another tiny mistake that people sometimes make. I'm now going to distribute on the left-hand side. Oh, question?
Can I do it?
Yeah, go for it.
So 2 times 3 plus 6 plus 2x.
Is equal to 15. Thank you, Sergio. And let's come back over here. Someone else. Solve the rest of this problem. Jessica, go for it.
You add 6 on both sides.
Careful. Right now it's a positive 6. How do I undo positive 6?
Undo a positive 6?
Yeah. How do I get rid of positive 6? Do I add or subtract it?
Minus.
Yeah, so minus 6 on both sides. I can kind of show my work down here. Minus 6. And our new equation, Jessica, is?
2x equals 13. Oh, 9.
9. Perfect. And then last step, Jessica, you got this?
Divide both sides by 2.
And what is 9 divided by 2? You can leave it, well, as a fraction, but as a decimal, it's 4 point... You got this, Jessica? 4 point...
I don't know.
You can call on someone else.
5.
Yeah, you got it. 4.5. Perfect. Done. Using our proportional triangles, using similar triangles, we know that this length must be 4.5, which is kind of cool.
That's like one of my favorite numbers.
4.5?
If I can get that number in basketball, that's my number.
4.5.
Okay.
Just get 45.
So generally speaking, if I have some sort of triangle over here, I'm going to make this a very general case if you want to skip over to just the answer, which I highly do not recommend. I do not recommend this shortcut at all. I highly recommend doing the full process so you really understand where the similar triangles are coming from, setting up these proportional triangles, but there is a tiny shortcut and here it is. I'm hesitant to give it to you. If I have C over A and D over A plus B, you will always get this cool little shortcut, which is if I do C times the quantity of A plus B will always give me A times D. And you can see that up here. This 15 was A times D. This tiny A times D, this 3 times 5 was indeed this 15. So that makes sense, that A times D. What about this C times A plus B? So this is C, this is C, this is C, that makes sense. And this 3 plus X, this A is 3, this A is 3, this A is 3. And then X in this case was B, and that all makes sense. So that's kind of just pulling from our example problem. There's your shortcut. if you want it. I highly recommend just setting up this proportion every single time though. All right, what I want you guys to do on your own or with people next to you, and you can get up and move around too if you would like, work on example 2. See if you can solve it based off example 1, and if you can't use that, then just use the shortcut. All right, good luck. All right, so example number 2. Is there anyone that wants to set up the proportion for me? I do not want to do the shortcut method. Sorry, Andres. Anyone want to set up the proportion? And maybe even before the proportion. Oh, wow, we are low on time. I'm just going to go through this with us. I'm going to take the steering wheel. Sorry about that. So I have a small triangle, and I have a bigger triangle. The bigger triangle has a length over here of 12 and x plus 4. The small triangle has a length of x and 8. So I'm going to do small over big in this case. Small over big. And it doesn't matter. I could have done big over small. So small is this small triangle. So it's x over x plus 4. That's not a 4. Is equal to this other length, 8 and 12. 8 over 12. All right, so from here, I'm going to cross multiply. Cross multiplying this direction gives me 12x. Cross multiplying the other direction gives me 8 times the quantity of x plus 4. And then from there, I need to distribute the 8. I get 8x plus 32. Left-hand side is still 12x. From there, I'm going to subtract 8x on both sides, minus 8x, minus 8x. And I'm left with 4x is equal to 32. From here, I just divide both sides by 4, divide by 4, and I get my final answer, x is equal to 8. Final answer, box it. I'm curious, can you guys give me a FIS of 5 for this objective, using properties of similar triangles to solve problems with embedded triangles? Quiet raise hands, FIS of 5s. How well can you do today's lesson? 4, 4, 4, 4, 5, 5, 4, and 4. All right, thank you guys. That concludes the lesson.